Hello. In this video, we're going to continue the conversation about geometric similarity. So let's do an example from the book Gulliver's Travels by Jonathan Swift. So in this book, Gulliver, the main character, travels to various lands, and one of them is named Lilliput. And what makes Lilliput interesting is that it's a land of people who are a lot smaller than Gulliver. And so that leads to the question of how they're going to feed him. So here's what it says in the book. His Majesty's mathematicians, having taken the height of my body with the help of a quadrant, found it to exceed theirs in the proportion of 12 to 1. So the question is, if the Lilliputians want to feed him enough food and drink, how much more should they give him compared to what they normally would eat and drink? So let's use an abbreviated version of the modeling process to try to tackle this problem. So that means we're going to define the problem. And for our purposes, let's focus on some assumptions. And we also need to define some variables. So let's let F capital D equal the amount of food for Gulliver and F little d equal the amount of food for a Lilliputian. And so what are some assumptions we can make involving these variables and some other variables that might be helpful? Well, one might assume that the amount of food for either is going to be proportional to the weight of the person. And we might also assume that the weight of the person is proportional to the volume. And then by geometric similarity, we know that volume is proportional to some characteristic dimension cubed. This is what we learned last time. Now, what characteristic dimension are we going to use? It could be shoe size, it could be hat size, length of your arm, or as we notice, in this particular situation, they measured Gulliver's height and their own height. So we're going to assume height. Notice that we have a transitive situation. Food's proportional to weight, weight's proportional to volume, volume's proportional to the characteristic dimension, which I'm just going to call d cubed if I'm talking about for Gulliver, and little d if we're talking about a Lilliputian. And so what that tells us, and now we can build the model. With all these assumptions, we can combine them into one model, and that's that the food of Gulliver should be proportional to his height cubed, or any characteristic dimension cubed. And likewise, the food for a Lilliputian should be proportional to their characteristic dimension cube. And we also know from the problem that the height of Gulliver is 12 times the height of a Lilliputian. So if we start putting these things together, according to this proportionality, we can write F sub capital D equals some coefficient times d cubed. But then capital D we know is equal to 12d, so I can rewrite this as 12d cubed, replacing the capital D cubed. We can rearrange things, k times 12 cubed times little d cubed, or what's the same thing, 12 cubed times k little d cubed. But notice this is the same thing as our proportionality over here. So what we really have is 12 cubed. And if you work that out, it is 1,728 times f sub little d. And so according to this, Gulliver needs 1,728 times as much food as a Lilliputian. Now we can analyze the model and ask ourselves, does that seem reasonable? It's a little hard to say because we're not there. We don't see what the relative sizes are, but in the book, it seemed like it was a satisfactory result for Gulliver. Of course, it's just a fiction book. But in terms of the first two stages of the modeling process, geometric similarity gives us an answer. And if we go back to what Jonathan Swift has to say, he says that they concluded from the similarities of their bodies that mine must contain at least 1,728 of theirs, and consequently would require as much food as was necessary to support that number of Lilliputians, by which the reader may conceive an idea of the ingenuity of that people, as well as the prudent and exact economy of so great a prince. So there you have it. You can decide whether that makes a reasonable model or not, but it did for Jonathan Swift and Gulliver, and we'll do another example in the next video.